Chemistry is all about fires and explosions, really, but we're not allowed to say that. So, but so I'm going to talk today about CK406. CK406 is an entry stream into science, chemical sciences specifically. But what it really is way in. It's not the final. You don't get a degree in chemical sciences. You end up coming up with a choice if you come in through CK406 of doing chemistry with forensics, chemical physics, or this year only, it will change after this year, science education via chemistry, because next year, 2023 entry will be direct entry for that course, but this year there is an option for science. Who am I? I'm Dr. David Otway. I'm head of first year in the School of Chemistry, so I look after all 600-700 students who do any of the chemistry modules, make sure the place runs well for the first year. Don't do it on my own. I have a very good team of technical officers who help me out, and I don't do all the lecturing. We share that across the sections, so I'm just one part of a very big machine. Why would you bother to study chemistry? Well, there's a whole load of things on there. There's the party line. Yes, it is. The key thing is, and it always rankles me, is that people say chemical free. Nothing is chemical free. Chemistry is everywhere. Everything's made of chemistry. My badge is made of chemistry. I'm made of chemistry. My coffee cup is made of chemicals. I'm drinking chemicals in my coffee. So, chemistry is everywhere. And it's the fundamental background science. So chemistry is the scientific understanding of molecules, their properties, and a fundamental science. So I'll give you some stats later on, but there are a huge number of career options that you can do with a chemistry degree or in chemical physics or chemistry with forensics. You are a problem solver and you gain a lot of practical technical skills. Excuse me, coughing. What is chemical sciences at UCC? Last year it was 532 points to get in. You need 184, 185 for 06s, 07s. You need maths and a lab science at some level. That points value was up from the previous year of about 470, the previous year before that of about 460. So it does move. What chemical sciences does is it provides you with problem solving, practical modern training, all branches of chemistry. There's some companies we supply graduates to. That's no means the minimum. There are a lot more on the following slides. Everybody has this notion that a chemist is just somebody who wears a white coat, mixes chemicals on the bench and studies things and analyzes stuff. But that's so untrue these days. It's not just that. No, you can be that type of chemist, but there are many, many areas you can go into. And we have graduates who go into a whole host of things that are science-based, chemistry-based, and outside of that, because as I said, chemistry is the central science. So we impinge on all of the sustainable development goals, and we come up with new ideas and new solutions. Mentioning the chemistry industry, why you might be interested in it. 24 of the top 25 companies in the world who work with pharmaceuticals or biopharmaceuticals are situated in Ireland. And UCC, uniquely, because most of them are based down in Cork, is set up to provide graduates for that system. Over 20,000 employees, most of them are above graduate level, and last year it accounted for about 65% of the GDP, 100 billion euros worth of exports. It's not all just about pharmaceuticals, though. We supply graduates to materials and microelectronics arenas. People like Intel, Apple, Hewlett-Packard, a whole host of other regions use chemistry. This is just breaking it down to show you where Ireland generates its income. Pharmaceutical products, organic chemicals, oils, plastics, medical apparatus. So all of this is underpinned, and there's food up in the top yellow. So there's a lot of stuff that chemistry gets involved with. Just some of the companies that we either work with, we have sponsorships with, we have research programs with, or we have graduates who go to. So if there are hundreds, and you're not closed to one door. And again, the final kind of slide in terms of the biopharma med industries, this is a couple of years old, but you can see Munster and actually most of the country, a lot of people employed in these industries, and there are always new jobs coming along. As I mentioned, you don't have to wear a white coat. the conventional examples where you might wear a white coat, you go work in pharma, biopharma, devices, or the kind of material side of things, or environmental. Unconventional examples go into patent law, banking, management consultancy. Half my degree course years ago went to work in the city as analysts because they're seen as problem solvers and good with numbers. So there's a whole host of things you can go and work in. So these are some of the questions that you good people sent in beforehand, and I'll try and hit on most of these as we go through. I'm not going to go through my list, they're kind of covered in the slides. I will return to them later on, just if there's any check there's nothing that I missed. In terms of the course itself, CK406, and again, just to clarify this, a lot of people make the mistake of thinking they're coming, they're doing CK406, so they're going to come out with a chemical sciences degree. That's not true. You come into UCC in an entry stream that's called CK406, chemical sciences, as opposed to maybe CK402, which is biological and chemical sciences, or CK401, which is computing sciences. They are entry streams. All of these entry streams then have degree outlets which you specialize in later in the years, whether it's at the end of second year, at the end of third year, or wherever. In chemical sciences, CK406, the first year is effectively foundational, and it takes what we've done at Leaving Cert, pushes it quite a bit further, gets everybody up to the same level, which is why you only need one lab science. Could be ag science, could be physics, could be maths, could be chemistry, could be biology. It doesn't have to be chemistry even, because we bring everybody up to the same level. There is a slight choice in first year depending on which way you want to go. So you do need to think forwards, and I'll explain the two options in a second. What the first year does is allow you to get a feel of the areas of chemistry and then make an informed choice and either go with the main chemistry degree. So if you picked chemistry, and I hesitate to call it straight chemistry because we are neurodivergent and LGBTQ, so I don't mean straight, but I mean just chemistry. It's not even pure chemistry, but anyway, not chemical physics and not chemistry with forensic science. If you just pick chemistry, you get a broad degree, and it allows you to not make too many early choices. There's no real quota on that. You do join students who come from CK402, who come through the more biological entry, who then make a choice between biology, chemistry, and the first year. You can also go into chemical physics. There's no real quotas on that. Quota is just a limit on the numbers of people who come into a module. Or chemistry with forensic science is an option. Or down the bottom there, science education. Like I said, that's only there for this year, and then that will be a direct entry. There are 20 quota places for forensics. Some of those come from CK402, but again, we've up until this very last final year, we've had no issues with quotas on any of our courses. So we end up with about 40 to 50, again, straight chemists, about 3, 4, 5, 6 chemical physics students. Some of those come from the physics and astrophysics entry, and then about somewhere between 12 to 20 chemistry with forensic science students. Again, some of those come from CK402. Just an advisory, if anybody is undecided between biology or chemistry, CK402 is the way to go. If you're more chemistry, physics, not really a big fan of biology, that's when I'd say CK406 is the best way forward. You do have to pick up a bit of biology, but not a lot. You can get rid of it really after the first year. I don't mean that in a bad way. So why would you do 406? If you enjoy experimental investigation, like working in labs, then that's kind of where we'll go. Bit of detail. Now, there's a lot of technical detail, and the key point is there's a core part that's chemistry. You then have a choice between option 1 and option 2. Basically, for either thing, when you start in year 1, you do about a third of your year is chemistry. A sixth is physics, and you get to choose either easy physics or hard physics. I'd advise easy physics, but that's just me. And maths, and then some biology or geology modules. Or you pick option 2 and you do some hard maths, some hard applied maths, and some very hard physics. That's what gets you into chemical physics. Only option 2 can get into chemical physics. All of this, so you don't need to remember all of this. All of this is on the web in what's called the UCC calendar. If you go and look at that, go to the UCC calendar, CK406, go and look at first year. All of this information is laid out in there quite clearly, and it tells you the degree outlets, so you're coming in as an entry stream 406, but your outlets longer term are there as well. Just a quick word about dates. University runs from kind of the middle of September through to kind of the middle of May, as long as you pass the first time. So the red bits on the screen at the moment are the actual term times, yellows are exam times, and then green is holidays. The pale blue down the bottom is holiday if you passed. So be aware that, that there could be some slight movement on those dates. In terms of what's in a module, so I mentioned the chemistry module there that I said was 10, you do a third of your year is chemistry. All of that, again, detail is on the web in what's called the UCC Book of Modules. This is just the Fundamentals of Chemistry 1, which we were doing semester 1. I look after that and I teach a third of that. And what these do is they're not really like a contract per se, but they're a kind of description of what to expect and how it's delivered and how you'll be assessed. And you can find this for every module in the university in the book of modules. It basically gives you an understanding of what you'll study and how it's taught. Just to break that down into a much easier picture, this is how a typical chemistry module in first year is assessed. Only about 45% of the module is assessed by a formal end of semester exam. 25% of the marks are based on practicals through the whole semester. There's continuous assessment in the way of a multiple choice questionnaire, which is done through our online virtual learning environment. And then you have weekly homework, which is basically there to help you understand the material and assess your knowledge. And all of that together comes together to give us 200 marks for that particular module. A year is usually out of 1,200 marks, just so you feel for that. In terms of a general work week, this was the first work week a couple of years ago, but this generally fundamentally hasn't changed. And this was for biological and chemical sciences, but chemical sciences is similar with a few variations. But the bottom line is you have lectures generally, which are the blue bits in the morning, and then labs that tend to move around. You don't have all three of those pink labs. They're different groups because you're joined together with biological and chemical sciences and spread through the week. So say you were doing physics, you'd have a physics lab when one of these is on, and say you were doing a biology module, you might have a biology lab. So the key thing about science is you work hard and you play hard, and it's a mix of those. It's nowhere near as onerous, maybe it's medicine or pharmacy, but it's certainly not an arts degree. A lot of people ask about what you do after first year. Well, after first year, you make a choice, whether you do chemical physics, or you do chemistry, or you do chemistry with forensics. All three of those groupings do a set of core modules, which are basically more advanced than the first year. Details on the screen there, I'm not going to go through all of them. And you get a little bit of choice, some elective modules, some biology, some maths, some physics. Forensics bring in, this is where they start to differentiate. They do the core modules with the main chemistry cohort, but then they can split up and they do some more biological side of things and some genetics and forensics, whereas the chemical physics degree course is basically more or less half chemistry, half physics, with kind of more of a push towards that kind of blend of the two. Third and fourth year carry on that theme. Excuse me, I just need to drink a bit dry. So in third year of the chemistry course, we split up into the traditional parts of chemistry: inorganic, organic, physical, and analytical chemistry. They are effectively 10 credits each of a 60 credit year. That's just the way we label things at university. And then you do some choice modules which allow you to inform yourself for fourth year. So we do environmental chemistry, pharmaceutical chemistry, materials chemistry. The reason we picked those three at UCC is they directly align to the research that we do at UCC, tied in with the Tyndall National Institute for Materials, the ABCRF, and the pharmacy building for pharmaceutical side of things, and the Environmental Research Institute for environmental. And most of our researchers work in one of those three fields. I'll show you a bit more on that later on. We do a soft skills module as well in third year. Fourth year is all about research projects. Most of your year, 20 weeks, so most of semester one and most of semester two are spent doing a research project with a member of staff on real world solutions or problems, whether it's analyzing data, whether it's working in the lab, whether it's going out in the field, taking measurements for the environmental side of things. So there's a whole host of different types of research projects are in there. There is some fundamental exams as well, but about a third of the year is based on your project. Forensics do a little bit more biology and toxicology in third year and do not do the choice modules, the environmental, pharmaceutical, materials. And in fourth year, they also do a research project and pick up some genetics and some pathology. Chemical physics carries on through third and fourth year as basically half chemistry, half physics, with the chemistry being the more analytical, physical, inorganic side of things and less of the organic chemistry side of things. Don't really need to go through that, but it was there. Practical classes, I'll leave those slides in there just for when maybe people want to ask. Just a bit of a jokey thing, just to mention, university is quite different to school. You're much more self-driven. So, it is all about, everything is on offer, but it becomes your responsibility to engage. And that's not just for chemistry, that's for everything. But there are many ways of helping you support things. A lot of people ask about jobs with chemistry, and there's a couple of bits of information on this slide. It's a little busy, but I'll leave it there for a few seconds. On the left was a 5-year trend showing over the years 2013 to 2017 where people went. And the bottom line is most people, if they wanted a job or wanted to do further study, did that. And this varies from year to year. Some people carry on and do a PhD in chemistry because that's what they're interested in. Some people go and train to be a chemical engineer. Some people go and do an education degree. Some people change from chemistry and go and teach. A lot of people go straight into jobs or go into internships. So there is those options. The last bit of data there on the right was the graduate outcome survey from 2020, and again showing similar trends. About 2/3 of the students that particular year went into jobs. About one student was looking for a job at that time, and everybody else, about a third, were doing PhDs, either at UCC or elsewhere in the country. And there's a wide variety of jobs and locations where these people went. And that's chemistry. This is the forensic science side of things. Excuse me. Talking too much, so apologies for the cough. And forensic science as well changes year on year. People are either going to further study, again, a range of different things, whether it's a master's or a PhD, because that's where they want to go with their direction, or they go into various different analytical or forensics type jobs. I mentioned the research strategy in the School of Chemistry. This is how we kind of all tie together. Chemistry traditionally is a mixture of organic, physical, analytical, and organic chemistry. But those areas are kind of more modernly associated with 3 different research areas, which are pharmaceutical, environmental, materials. We interact with those 3 major research institutes, which we're very lucky to have access to, as well as all of our industry partners. That's just some examples, because people in the questions asked about what type of research do we do. There's a few examples there. So we look at making new drugs. We look at looking at how they're made. We look from I'm an inorganic materials chemist myself. So we look at anti-cancer drugs, new materials for phone screens and batteries, and DRAMs, and new materials for polymers and plastics, and aerosols, and all sorts of things. We do a lot of analytical chemistry. We're very big in the department on environmental chemistry. Probably may have seen over the last year and a half, one of our professors, Professor John Wenger, very vocal about atmospheric chemistry. He's a particle chemist, and so he had a lot to say about the use of these and why we really needed to use these when COVID was very high and turnover of the air. So that's kind of atmospheric chemistry side of things. So questions. As I said, there are no stupid questions, only those you don't ask. That was